All right. Well, hello, everyone. Welcome to the Monroe Live podcast. I'm your host today, Scott Hoffman, and with me, I have the pleasure of introducing Mr. Ben DeLand, Director of Electrical Hardware Engineering at GKN Automotive, which you're just down the road in Auburn Hills, right? A corporate neighbor.
That's right. Just a mile up the road on Opdyke there.
Yeah.
And thanks for having me. It's a real pleasure to be on. Big fan of your YouTube channel and what you've been doing there to get information out.
Well, thanks, Ben. You're too kind. I look at your title and some of the stuff I've read. I think you have some good articles and stuff out there. I read them. I'm like, I look at the stuff you're responsible for in your team, and I don't know how you have the time to carve out to come in and do this. So sincerely, man, we appreciate you taking the time to come in and sit down with us today.
It's my pleasure.
So, Director of Electrical Hardware Engineering at GKN, obviously a huge automotive player. We'll get into maybe more about GKN in a bit, but maybe you could tell us so electrical hardware within the GKN portfolio, what kind of components and items in a vehicle does that mean that you guys are responsible for?
Sure. So GKN Automotive is a big player, starting off with side shafts. In the 1950s, GKN, as a parent company, entered the automotive market. So GKN Automotive began innovating in side shafts and constant velocity joints for drive shafts, and then acquired a portion of Getrag's business, their driveline business, and got into the all-wheel drive space.
Okay.
And gearbox design with that as well. And with those all-wheel drive components and electric drive components, you need the electronics to drive them. So that's where my team comes in.
Okay.
So we do ECUs for our all-wheel drive products. We do inverters for our eDrive systems as well.
Got it.
And my team also manages the actuators and components that help drive that system.
Sure.
So if you have low voltage motors or solenoids, harnesses, sensors, that type of thing is also managed by my team.
Okay. Wow. So yeah, I mean, traction inverters, as we think about like EVs and electrification, that whole space, like a pretty critical and important component in terms of propelling an EV to do what it does. I guess we find that a lot of folks that watch the channel are interested in vehicles and in electrification. So maybe for the uninitiated, could you maybe just kind of summarize what it is that an inverter does in one of your guys' eDrive units?
Yeah, great question. I think it's important that we level set on the language for EVs because everyone is learning, transitioning from ICEs with combustion engines and transmissions into this totally new component.
Sure.
So often people refer to an eDrive system as a motor, an electric motor, but actually it's three parts.
Yeah.
It's a traction motor, it's the gearbox, and the inverter. So the responsibility of the inverter is to convert the energy from the high voltage battery into an AC waveform that is driving the traction motor. And the traction motor is then creating torque and sending it to the gearbox. The gearbox is multiplying that torque and sending it out to the wheels.
Got it. Yeah. So, and I think it's funny too, inverters, like you hear it, some people, I think we even did for a while, call them inverter converters, right? Because with an e-motor or e-machine, you can have regen, right? So from the battery, you've got the DC power, you're inverting it to AC, going out to the motor, and then it's converting it back. And I may be off here, so feel free to correct me, but coming back the other way, if you're coasting and that's spinning down, you can send power back to the battery, sort of doing the same thing in reverse. And I think the inverter is still managing that in that scenario, right?
Absolutely. Okay. You're absolutely correct. So that's the major benefit, or one of the major benefits of an EV, is that you can recoup some of that energy from the wheels and send it back to the battery. And it absolutely comes through the inverter again and charges the battery back.
Yeah. Awesome. Yeah. So, and I guess just for those who maybe haven't torn down an EV, any drive unit that we've seen on the floor, right? They're always going to have an inverter. Ben mentioned 3-in-1. That is sort of become what is most common, I feel like, that we see out there in terms of having the inverter, the gearbox, and the e-motor or e-machine all sort of as one neatly bundled unit. But that sort of wasn't necessarily the case in the earlier days. Would you guys say that in your product portfolio, is 3-in-1 pretty standard now, or do some folks, is there still a reason to do, I guess it'd be a 2-in-1 with like a separate inverter?
Yeah, so GCAN Automotive is happy to sell full 3-in-1 systems,
Sure.
as well as individual components. So there are different situations that our customers ask for. In the end, it's coming into a 3-in-1 unit. So it means there's more integration now than there was in the past.
Sure.
Now, whether that gearbox is being supplied by one supplier versus the inverter coming somewhere else and the traction motor coming from a third place, that's kind of immaterial. But those systems, those subsystems need to work together to combine them into an integrated unit.
So you guys do, that is a scenario then that you encounter where maybe clients would want to use just a portion of your offering and pair that with something that either they developed internally or might even come from another tier 1 or tier 2 altogether?
Could be the case, yeah.
Gotcha.
Happens quite often.
Yeah.
So
okay. Well, yeah, and as we think about like, especially your guys' driveline components, you know, the shafts are always mating up to like something that's driving it that probably came from someone else, and wheels and hubs that are probably from someone else. So you guys are like awesome intermediaries for the transfer of power, I feel like.
Yeah, you know, we're one of the only companies that can transfer torque or generate torque in the eDrive unit and transfer it out to the wheels through the drive line.
Yeah.
So we have that full integration capability in the portfolio.
Sure.
And that helps a lot with management of noise, vibration, harshness. If you're owning different parts of the system, you know how they join together and what the levers are that you can pull to have the best integrated system there.
Sure. And I know you mentioned, so the ECUs, electronic control units that would be driving the all-wheel drive systems. I know, you know, in ICE vehicles primarily, you're then talking about having either transfer cases or PTUs or, you know, disconnect systems, clutches, differentials, all that good noise. I guess, so historically that probably, I know that was, I was looking at some of the roles you held, it seemed like you spent some time there and have now gotten to where obviously in the electric space or eDrive space, you're doing a lot there. What was, I guess it would seem that like the controls of that all-wheel drive stuff, you probably had some important learnings there that kind of led to where you're currently at. Maybe you could talk about how that sort of transition took place and maybe why that was good or bad or what that meant for you.
Yeah, I think there's kind of a beautiful story at GCAN Automotive. Okay. You know, you think about starting in the 1950s and 60s with side shafts in constant velocity joints. Mm-hmm. That's a very mechanical component that is based on transferring torque.
Yep.
But over the years, you learn about noise, vibration, harshness management. You learn about torque transfer through those devices that makes it kind of a natural transition then into an all-wheel drive space where you're responsible for managing torque. So you're not generating torque, but you're managing the torque to each of the wheels, right? So you have torque delivery with the side shafts, and you have torque management with all-wheel drive. And in all-wheel drive, you get a lot closer to the vehicle dynamics, to the vehicle integration with the eventual customer, with the OEM. And you're doing a full mechatronic system at that point. So you're managing things like functional safety, like cybersecurity for your units. So it's really a transformation of the company to be able to manage a complex mechatronic product that is responsible for lateral dynamics in the vehicle. And that is very easily translatable then to eDrive systems. You're taking a differential from an all-wheel drive system. You also have a differential in every eDrive system, right? These same sort of lateral dynamics play that happens in all-wheel drive, you also see these in eDrive systems. The software foundation that you've built with all-wheel drive translates there as well. The electronics platform, although it's low voltage on the all-wheel drive side, that's really just a control board inside the inverter. So there's a lot of nice play there that allows you to take the progression from step to step.
Sure. So you guys had a running start. It was like it was a match made in heaven. It was perfect.
A running start starting in the 1950s. Yeah,
yeah,
exactly.
That's neat. No, and I saw too. So you talk about the portions of the vehicle that covers. Obviously, you think GKN, you think driveline and sort of powertrain and the transfer of power. I know it looked like you'd spent some time also in like braking hardware and chassis dynamic hardware. So again, as you think about continuing out to the wheels and managing torque, it seems like you've had a lot of experience both in and outside of GKN even that kind of equipped you for managing that scenario.
Yeah, that's right. So the controlled brakes experience was my first position out of university.
Okay.
And that was with a former Delphi company that was transitioned to BWI Group. And it was the perfect situation for me as a young engineer that was eager to learn about the industry and the development of automotive electronics. And here you had a place where you had a lot of former Delphi guys that were extremely experienced, had built some of the first systems in vehicles, and were just very eager on their side to pass down this knowledge.
Sure.
So it was the perfect pairing there of allowing myself to develop, and they were able to pass down the knowledge. I'm forever grateful that was my first position.
That's awesome, man. Yeah. Well, and I'm always curious too, like, you look at where you're at today, you're a leader of teams in a pretty critical area of current vehicles and the next generation of vehicles. I guess if you looked back at like 8 or 10-year-old Ben, and you looked ahead at your future, is this where you saw yourself? Was this, would Ben be surprised, or would you have been like, oh yeah, man, that's going to be me?
I would say I had no idea. When I was 8 or 10 years old, I was much more interested in sports and the physical play.
Sure.
I don't think I had the traditional engineer's mind growing up, where it was obvious that I was going to be an engineer. I was good in school, strong in math and sciences, and I think you get some external pushes from your peers to say you should be an engineer. And I probably didn't even know what an engineer was at that point in time.
Sure.
But that's what I stepped into, and it was more of a grown love over time,
taste,
an acquired taste. That's right, rather than something that I was born to do.
Sure. Well, you mentioned you were big into sports. What was your childhood favorite sports, man? What did you do?
Oh yeah, well I have 2 older brothers that I was always trying to catch up with. So we were always playing basketball, football, baseball together. So a lot of experience in my childhood. I grew up kind of in the country, so sports is where you dove in. That's what you do. So
I'm with you too. Growing up, my parents, like we were fortunate enough to have like we kind of lived in the woods, like almost in the middle of nowhere to some extent. And it's fun. You get to, it's nice to have space to get out and do stuff. And I feel like too, even though I would say I wasn't ever like dead set necessarily on becoming an engineer, just like having some space to be able to rip things apart and look at things kind of helps stem some of that curiosity for developing things. So I think I saw too, though, on the topic of athletics, and this may be a tangent, but did I see that you used to play some ultimate frisbee in your day?
You're right. Okay. Yeah, I played ultimate frisbee in college.
Okay.
Yes.
Okay.
So it was a club team. So, we took ourselves seriously in some ways with the athletics, but it was also just a great group of people.
Sure.
A ton of engineers, for some reason, also play ultimate. So it was a good community there. So that involved a lot of travel on weekends in college to different places around the country to play in tournaments against other universities.
Sure.
So it was competitive, but also very fun.
Ultimate's a ton of fun, man. I feel like if anyone's not spent an ample amount of time around a frisbee, it's because it's competitive, but it's not too serious, right? And I think my my little brother was on an ultimate team. He went to Hope College, so on the west side of the state. I don't know if you guys ever played them or whatever, but yeah, he was always going to the tournaments and stuff. I like throwing. I was never probably very good at it, but do you still huck, man? Are you still out there spinning discs?
Yeah, well, I have 3 small children at home, so the days of competitive ultimate are over, I think. But I'm eager to get my 4-year-old out there with the disc and teach him some things.
That's got to be, I guess people think about learning to throw a baseball or a football. Frisbees, I don't know. Is that for a little kid? Do you think that'd be harder? I don't. The forehand or the what is it when you throw like that?
The forehand.
Oh man, that's how you separate the men from the boys. And
you have to start them young. I think that's the key.
There you go. Awesome, man. Well, do you need frisbee golf? I know that I have some relatives that are really into that. It seems like that'd be a natural transition.
Sure. Yeah, that's the more dad-friendly sport, I would say. So yeah, awesome. We get out from time to time and do that as well.
Awesome. Well, I know we're kind of jumping all around here, but wanted to circle back a little bit to your company, GKN. I think I was looking, I'm always interested when there's an acronym, like what does that acronym stand for? And it was, correct me if I'm wrong, I think it was Guest, Keen, and Nettlefolds.
You're correct.
Going all the way back to like the mid 1700s or something like that, right?
Yes, right.
That is some storied history, man.
Yeah, so GKN has quite an extensive heritage. So started out as an ironworks company in England, founded by Guest, Keen, and Nettlefolds, and
household name.
Yeah, exactly. And now it's really humbling to think that the company has been around longer than the United States of America has been formed. So it's pretty incredible to think like that.
Yeah. And I think, obviously maybe the nature of what we do, or at least personally what I've been exposed to, the automotive side and maybe a little bit of the powdered metallurgy, like I've seen your guys' products, but I think company-wide, you guys are players in like aerospace and some other industries as well, right?
Yeah. So about 4 years ago, I think it was 4 years ago, maybe 5 now, GKN as a parent company was acquired by a different company, Melrose. Melrose Industries, in a takeover. And with that takeover, we were pulled into Melrose Industries business, and they split up GKN Automotive from GKN Sinter Metals from GKN Aerospace.
Sure.
So they held on to GKN Aerospace, but recently GKN Automotive and GKN Sinter Metals were put back on the public market under a parent company called Dowlais, and we're now independent and public again.
Okay, yeah. So it was like I was reading something about that. It was like a demerger, and it was like real recent, like within the last couple of weeks or something.
Yeah, just 2 weeks ago, I think.
Okay. And I was looking, Dowlais had something to do with like a throwback to like the Dowlais Ironworks and like where they licensed the Bessemer process from, right?
Yeah, you've done your homework. Wow, well done.
I
didn't know there would be a history quiz on this, but
no, it's great. Fun, man. It is. I feel like not every company has that rich of like a heritage and that cool stuff. So it was out there. I was like, I was interested, so I kept digging.
Absolutely. No, I'm into it as well. It's fascinating.
Gotcha. So then the company then is headquartered, I guess, globally. Is it in the UK or?
It is, yeah.
Have you ever been over there and visited?
I've been to our Advanced Technology Center in England, but not to the headquarters itself. Okay. So we have an advanced development center near Oxford in a city called Abingdon, where they're looking at the technology, 5-10 years down the road.
Got it.
Yeah, so they're doing some fun, interesting things there as well.
Very cool. And that's got to be interesting. I mean, I imagine, obviously, we live in a global economy. Products that OEMs are developing are going all over the place. I imagine the parts that are on them as well for you guys. So you're probably managing development and teams of folks from all over the world. What I'm trying to think, like what time zones are you typically balancing in your daily foray?
Yeah, so I'm typically an early morning guy.
Okay.
So a lot of business is done with Europe, but also with Asia. Okay. So there's no perfect time to do it.
Yeah.
But we have an electrical hardware team in India, so I need to interface with them from day to day. So they're 10 and a half hours ahead. Means some early mornings.
Yeah.
But
yeah, trying to balance between, I remember one time I was trying to do it with Vietnam and the UK and here, and it was just like, there was only like 1 hour in the day. I felt like that was some sort of tenable thing for everyone.
Right.
So
it's like 6 a.m., something like that.
Brutal. Yeah. Well, you've got young kids. I was never a morning person, but I'm sort of begrudgingly becoming one, I feel like, because you're forced to when you have little kiddos. So hopefully they help make that transition smoother for you.
Well, yeah, that and the working from home possibilities that opened up after the pandemic, right? So, I can roll out of bed and 15 minutes later be on a phone call with someone in Europe or in India. So that's the benefit there.
There you go. So that's how you manage it. Awesome, man. Very, very cool. So I guess one thing I was wondering about, so you kind of started off in brake system like management, the controls behind that, looked like you did some stuff in chassis. And then obviously at some point you made a transition to GKN and sort of got on this path towards, being in a crucial part of the hardware for, the things that make EVs go, right? Was that an intentional decision you made? Like, hey, this is where I think the industry is going. I want to make that move and be in that space, or sort of what transpired to get you from sort of where you started out to where you are?
Yeah, that's a great question. Probably I was very young and naive at the time. Sure. I wish I could say it was intentional, but things just kind of work out in life a certain way. I was ready to take a step in my career to branch out to a different product and to build something. In controlled brakes, we're making great products, but it was very mature, and braking is very commoditized. Sure. So I was looking to step into a space that I could build something new with a team and make more of an impact. Sure. And that's what GKN Automotive offered to me. It allowed me to go through this transformation of the business along with them, from a purely mechanical company to one that is driven by systems engineering principles, and one that values software and electronics just as much as the gearboxes and the side shafts that we're putting out there. Yeah. So from that perspective, just building products along with an organization that was open-minded to change, that was the perfect match for me.
That's neat, man. It's I laugh. I think about my first exposure to some of GKN's products would have been, like on a half shaft. I think that one of the neater innovations I saw, it was like the face spline hub, where it like goes to the hub and you don't have a pin that's going through. And I think it was a BMW we were tearing down, and we were looking specifically at like weight optimization opportunities. And that was it. It was like you hacked off a bunch of material, you had a single fastener, it was easier to assemble. It probably cost more, so that was maybe the trade-off. That's probably why it was on a BMW, but I would like to have that technology on my car. I was impressed with it, but obviously that was more in the sort of mechanical realm. Neat to see how the portfolio is sort of expanded to have the products that like you're working on. That's very cool. I know that was like an innovation at its time, and I looked up a bunch of stuff about it. I would imagine there's probably similar innovations that you and your team have developed that you're proud of. What is kind of, I guess, in the products that you've worked on or managed or led the development of, what are maybe some of are there any sort of innovative developments that come to mind as things that like maybe the casual observer wouldn't notice, but just neat things that you were proud of that you and your team brought into an inverter or into an all-wheel drive control system?
Sure. Yeah, we're doing a lot of great work there. So I think in the industry right now, as it should be, there's a major focus on efficiency. So that's a key focus for us internally as well. So making the units smaller, making the the runs of the bus bars that are delivering the power as small as possible, making sure the packaging is compact, having efficient power stages to deliver the power from the vehicle battery to the traction motor. That is what efficiency is, right? Sure. The better you can deliver the energy from the battery to the traction motor means that you're a more efficient component. So that's where our focus is. I think we've done some really excellent work there with cooling of power modules, with our packaging to reduce mass. A lot of things we're really proud of there.
Yeah, it's neat. It's an interesting time in the sense that, I think in the last year, at least 20 different EVs from all different OEMs have come through, and you look at them, whether we're tearing them down or putting them on the hoist, and like the industry hasn't really totally converged on like what is the most efficient, right? Absolutely. People are still doing things different ways. Their supplier partners, tier ones such as GCAN, such as yourself, are doing things different ways, and it's exciting to be at a moment where everyone's still trying to figure it out, and you can experiment in some of those ways and see. I mean, I imagine, my feeling is things will probably continue to converge, and we'll get like a rough idea of maybe the more efficient ways to do things. And I guess ultimately people come to us asking about some of that and trying to see like, hey, where are the efficiencies here? But it's I guess like, so like the move to, I know we were talking about, and we should bring this up, the Mach-E, which we've torn down. You guys had some content on that. I think the front drive unit, right?
Yes.
And I believe we mistakenly called that a Magna unit. So I would like to apologize. I don't even remember who said it, but
it was Sandy.
Okay, it was Sandy. Well, Sandy, darn it. We'll have to talk to him about that one. But tell us about that drive unit, maybe, if you're familiar with it. I know we saw it out on the floor before we walked in here. Was that something that your team touched? Yeah.
So that video was excellent. Sandy was kind of swooning about the front unit and the Mach-E, and he says, "Yeah, this gearbox here is from Magna."
And you guys are like, "No."
I think there was a mob assembling, up the road, ready to march down here and have some bones to pick. But no, I understand in your work it's impossible to understand, the full supply base there. But that's a great unit that we have in the Mach-E. Mm-hmm. It's a 2-in-1 system for GCAN. So what that means is we didn't supply the inverter.
Okay.
We were responsible for the gearbox and traction motor.
Okay.
And delivering that with an interface to Ford that they could make the inverter.
Okay. Yeah. Well, you're kind to give us some dispensation. It's still a pretty big whiff. I apologize for that. I feel bad. Now I'm going to go rewatch that video, and maybe we'll amend it in some fashion, but it's not the first time that's happened. Probably won't be the last, but we do try and be as accurate as possible. So thank you for setting the record straight on that. Absolutely. One. Appreciate it. And it's interesting with Ford too, as I think about so we looked at the Mach-E. Obviously, that was sort of their first recent meaningful jump into the electrified space with a full BEV. I think they did a great job with that vehicle, and I'm seeing more and more on the road. But in that one specifically, their drive units, their EDMs, they had a 3-in-1 in the rear and a 2-in-1 in the front, and they were from different suppliers. It's interesting to see as we compare that to like the F-150 Lightning. Ford has taken on the responsibility of doing their e-motors in-house now. I think I think they are doing 2, and maybe you know more about this than I, and if you can speak about it, feel free, but they're still purchasing their inverters from what we see, but I think that the other 2 functions, maybe they're taking responsibility for. Mm-hmm. Conventionally speaking, when we think about, the days of yore, ICE vehicles, the conventional OEM responsibilities were your body in white and your powertrain. And certainly there's some exceptions, but by and large, those were the 2 big ones. In the early days of EVs, it made sense for people, speed to market and everything, to kind of maybe buy more than build. Do you guys do you guys have a sense, like, is there a concern that moving forward, OEMs are going to try and claw more of that content back to themselves to try and, be more competitive, or do you feel like you guys have a pretty stable, maybe you can do it better than the OEMs? I don't know. Maybe that's the pitch if you have more experience in that. But do you think we're seeing a bow wave of appetite for EDMs being done externally, or do you think that'll be a pretty sustained appetite?
Yeah.
And it's a tough question.
No, it's an excellent question. Yeah. I wish I knew the answer. But, so I think it varies a lot right now, even between OEMs. So some of our customers are doing all of their systems in-house. Some of them are doing their full system externally. Some want components with their own system responsibility. It varies a lot. Mm-hmm. I think if we look at the past with OEM development of whatever component, pick a component, they want to build that competency in-house for themselves so they can see eye to eye with the supply base. Sure. So it's important for them to do at least some systems, sure, it seems, so they can manage a supply base intelligently. Okay. I think there are a couple of factors that will affect it going forward. One, it is clearly the engineering focus right now for our customers that, this is the transformation space from ICE to battery electric and PHEVs. Sure. Will that continue in the future? I don't know. Will they turn their focus toward autonomous driving? Sure. And turn their workforce in that direction? Sure. And the other aspect would be, are they getting any competitive advantage from doing it in-house? Are they able to differentiate with doing that work in-house? I think that's also an unanswered question. Sure. The generation of EVs that we're in right now have focused on longitudinal dynamics rather than lateral dynamics. Yeah. I see that as an opportunity for a company like GCAN Automotive that has so much experience with lateral dynamics that can make your driving experience unique, right? We have the all-wheel drive components that can be building blocks for an EDU and help our customers then get a different driving experience out of it. So I don't know the full answer, sure, but I do see that next generation of EDUs being built with some further differentiation coming in the way of lateral dynamics. Sure. And I think they'll be reaching out to the supply base for support in that. Sure. Does that mean full systems or does it mean components? I don't know, but we're experienced and prepared to do both. Yeah.
Fascinating. And I know, and it's interesting too, you think about, are they differentiating with it? What are the important factors to the end user? I think we're still in this space where efficiency is paramount because people are thinking about range and how far the vehicle goes given a certain battery size. And as I think about some of the things, driveline systems and components that we've seen starting to talk about, like disconnects. I know we had a Rivian out there. They had a set of electromechanical disconnects that allow them to decouple. They had 4 motors, which is excessive, right? But they had an ability to decouple the rear drive unit, essentially both of the single drive unit that had 2 motors. They could decouple the thing. And I know we've heard, historically, units to decouple the powertrain were certainly in ICE vehicles, again, for the means of efficiency, not just having all that rolling resistance on your drivetrain. Do you guys, in terms of other portions of the driveline, do you guys have any disconnects, decouplers, clutches? Is that kind of your wheelhouse as well?
It's a big part of our business. Okay. Yeah. So you're absolutely right. Disconnects in ICE vehicles. So if you have an all-wheel drive system in the rear of the vehicle, you have to have a prop shaft from the front of the vehicle to the rear of the vehicle to send that torque to the rear wheels, right? And if you're in a situation where you don't need all-wheel drive for the vehicle, it's better for fuel economy to disconnect the all-wheel drive system from the driveline. So that's a big part of our portfolio. We also are big into secondary drive axles for eDrive systems. So by that I mean it's not the primary driver of the vehicle, but a way to accomplish all-wheel drive in electric vehicles is to put an electric drive unit in the front, an electric drive unit in the rear.
Yep.
So if you're the secondary drive unit, you're oftentimes not having the same power to drive the vehicle. You're oftentimes not asked to supply power to the vehicle.
Sure.
And if it's a permanent magnet motor, it's providing drag on the vehicle, reducing efficiency.
Yeah.
So in our electric drive units also, it's extremely important that we have a disconnect that offers as high efficiency as possible.
Sure. Yeah, well, and I guess that's an interesting topic too. Conventionally, if you've got an ICE engine, that's redundant. If you've got an ICE and you're trying to transmit power to the rear conventionally, you've got the prop shafts that are sending that with differentials. I remember the first time I saw like a P4 setup where it was an ICE engine up front. I did it again, with an electric drive unit in the rear. So there wasn't the shafts. I think it was like a Volvo XC90 I saw that on. I think you guys have some of those systems out there in the wild as well, right?
Actually, on the XC90.
Okay, is that, I was thinking,
Yeah, exactly. Okay. And there's a disconnect unit in there to decouple that permanent magnet.
Okay, when it's not asking for, because it's permanent magnet. If it was an induction motor, maybe it wouldn't be necessary, but then you're dealing with an induction motor. So interesting, fascinating. So man, I think about, we talked about sort of the state of flux of the industry and things moving around. And certainly there's a lot of momentum, I would say. EVs are having their day, but at the same time, talking about things not converging, like I think about the last 3 EVs that we've torn down. We've got a Hyundai Ioniq 5 out there. We had a Lucid Air in there. We had a Hummer. So those would all be 800 or 900 volt cars, which early days, everything was 400 volts, more or less, nominal ranges. I was really curious. There's a lot of discussion about what high voltage EVs are going to be at. I think Tesla for a long time was saying, nope, no plans to go to 800 volts. But then now the Tesla Semi's at 1,000 volts, and I think they're talking about going to higher voltages. They are on the low voltage side. I guess I'd be curious, as someone who, from the inverter side, you're having to take power from the battery, so this is probably core to you. What's kind of your thought on the whole maybe move to higher voltages? Do you think 800 volts is it? Do you think they're going to go to higher voltages? And how does that impact like an inverter, how you guys design that? What components does that change in a piece of hardware like that?
Sure. So first, we should level set for the audience why we should go from 400 volts to 800 volts in the first place. And that is really all about efficiency, in my view. Some would also say it's a chase of power. But power losses in electric systems are due to current. So current that is not driving the traction motor, or current that is through the system, is creating loss through heat.
Through heat that you have to then manage with a thermal system, or thermal management
Exactly.
system. Yeah.
So power is voltage multiplied by current. So if you have a higher voltage, it means you can have a reduced current with the same power output. So that's the case for going to 800 volts, right? So the benefits of that are, if you have the same power system, that you can reduce the size of your components.
Yep. Down gauge wires, reduce size.
Exactly. So,
and even the components, though, you're saying, I guess that makes sense.
So inside the inverter, it means that the bus bars can be reduced in diameter, or in
cross-sectional area.
Yeah, exactly. However you want to measure it.
Sure.
The power module can be reduced in size as well, so you have less power losses there.
In the actual power switching components within there, which are like the highest dollar item probably in an inverter, right?
Absolutely the highest dollar item, usually between 40 to 50% of the cost of the inverter. So you can downsize those components as well. The whole package can shrink. So you get some really major efficiency benefits by going to a higher voltage level.
Sure. Sorry, I hit the table. I was just so excited about the efficiencies, man.
Yeah.
But yeah, so there's a compelling case, and obviously we're seeing folks do it. Do you get the sense that, like, in your world, does that seem like a no-brainer? Is that like, yeah, this is where we're going?
So 800 volts for sure.
Okay.
At least in my view, that is going to be the world going forward.
Sure.
Can we go beyond that is the question at hand. So I don't know the answer to that. I think it's worth exploring though. So when you have high voltage, you have to respect some design rules regarding, clearance and creepage to keep components spaced enough that you're not going to have some voltage jump that shorts out the system.
Sure,
right?
Welds things shut or whatever, yeah.
So that's the challenge with going to higher voltage is you need to respect these different constraints of the system. So increasing the voltage further means that you need to respect those clearance and creepage rules even further. So there's a limit there that you reach where it's no longer worth it to increase voltage because of the rules that you have to respect are prohibiting some of the advantages that you would get.
Sure. We know for their low volt side of things, we know Volkswagen, many other companies have been playing around with that for years. We know there's mild hybrid systems that Ram with the eTorque setup has a 48 volt battery that's part of its driveline. But I know all of your guys' systems have a low voltage component to them as well. What's your thoughts on the whole 12 to 48 volt topic? And do you see that in the same way that you see the 800 volt discussion in terms of it being maybe an obvious choice or an inevitable thing? Or do you think the reason I ask on that one, it's been being talked about for so long, but it's like we've not gotten off of square one. So it makes me curious. I don't know. I really don't know. I'd be curious on your opinion on that.
Yeah, so I see that one in a bit of a different way.
Okay.
Personally. Now, I know that there's some disagreement out there. So we talked about the step from 400 to 800 and the gains in efficiency there by reducing current. You could apply that same principle from 12 to 48 and say you're also going to reduce current. But the low voltage systems in your vehicle that are drawing sizable amounts of current are, you have some pumps, maybe
fans,
controlled brakes, that sort of thing. But the amount of systems where you would see a benefit in the current reduction, I think is quite reduced.
Sure.
If you look at the inverter itself, so you mentioned that it has a low voltage component as well. We would call that the control board.
Sure.
Right. So it's receiving 12, maybe upcoming 48 volts into it.
Sure.
It's not a big power draw into that component. That area of the inverter is what is controlling your disconnect devices by driving a motor or some of the other lateral dynamics capabilities that you might add in there on the all-wheel drive side, driving some motors. So you get some benefits in current reduction there. But overall, that portion of the inverter is not a high current drawing device. So the efficiency benefits that you would be getting there are much reduced.
Sure.
Then if you look at the architecture of the board itself and the voltage that those subcomponents want, and really what the whole industry of subcomponents has been building for years and years and years has been based off of this 12 volt architecture. So for me, that's a huge investment to go to 48 volts for something that I don't think you're going to see a ton of benefits in, certainly for every system. So it's an open question out there. I'm really excited to see what happens with Tesla. Everyone says that what they're doing is stupid and they pull it off, you know,
Sure,
so that they're transforming the industry. So I'm excited to see what comes out of that. So we're keeping a close eye on that for sure. But for now, I like my 12 volts on the low voltage side of the inverter.
That's fair. That's fair. Awesome, man. And just thinking about some of the other systems that are like maybe in a state of transformation, and specifically thinking about your wheelhouse and things you've worked on, I was curious. There's several things actually. I was really excited to talk to you, but like I know another area where historically, like in the driveline, in automatic transmissions, you had a torque converter that would sort of idle forward if you left it in neutral. So you had a park lock system, a parking pawl, something that mechanically would lock in and stop the vehicle from moving. We've seen in the advent of electronic park brake systems, right, people now have a means of electronically, through another mechatronic element, holding the vehicle stationary. And we've seen some OEMs use that opportunity to take a park lock system out of their eDrive unit on BEVs. I think Tesla was the first place we saw it, but Volkswagen followed suit. Polestar does that. I've seen, Rivian didn't have any in their drive units as well. Curious what your, especially since you spent some time in controlled braking systems too. Like, what is your thoughts on that? And I guess, I don't know, would GKN support? Do you have products that do and don't have a parking pawl? Is that purely up to the OEM, or is there like I guess the verdict's still out. I've talked to people and there's no clear guidance regulatorily. Just would love, as an expert like yourself, I'd love to know what you think about the topic.
Yeah, so it's an open question, I think, clearly in the industry. So we have customers that they want to have this conversation in the quotation phase about the system, whether it should have a park lock system or if they're going to an electronic park brake. I think it's a functional safety question. It's one that all of our customers are trying to answer for themselves, and we're acting as a consultant there. So we're happy to support it either way. It's an issue for the customer to resolve, but we don't see a clear resolution of the question. Certainly from the cost driver standpoint, you could make a good argument that the trend will continue for elimination of park lock systems, but maybe because of functional safety concerns or government regulations, that won't be the case.
Yeah. That's a very diplomatic answer, man. I appreciate it. No, it's good. I mean, you have to have an approach like that. Yeah. Cause if you put yourself out there and things change, that's been the most interesting thing for me is people have asked us about this, right? And as you look into it and you read some of the guidance, whether it's EU standards or FMVSS stuff, a lot of it's describing like mechanical systems that aren't even in EVs, right? It's talking about automatic transmissions, and it's talking about ignition systems that have hard keys. And it's like, we got to update this stuff. But I get the sense that they're kind of hesitating because they're just like, it's a big deal, right? There are real implications. People are going to take action based on that update and guidance. And it's just kind of a gray area.
And the industry is moving really fast right now too, right? So if they make a new standard right now, is it going to hold for the next 10 years, 20 years? The interesting thing is, ICE vehicles have been developed for 100 years, and we've been developing battery electric vehicles for the past 20, and only probably for the past 5 or so with some real engineering weight that's going into it. So we're early on in our stages there of what systems we're going to see going forward. So it's really an exciting time.
Yeah, for sure. And even I think about like electrified elements that aren't necessarily even exclusive to BEVs, but things like steer by wire, brake by wire, electronic brake boosters, which again, I feel like would have been in your sphere of influence at one point. I know that I saw Toyota's supposed to be debuting a full steer-by-wire system on, I think it's the Lexus RZ450 or something like that in the next year or something. I think we're close. I know Sandy's talked about that for a long time. He thinks, oh yeah, we should definitely do it. So no mechanical linkage between the steering wheel and the rack, continuously variable ratio, no hand over hand, so you can go to full lock, and they're just adjusting it. What's your take on steer-by-wire systems?
Oh, wow. Yeah, we're really outside my realm now.
Well, it's fine. If you don't have to go there.
So I think the interesting thing there is without hand over hand, your steering wheel can be a different shape, right?
Yeah.
So it speaks to some different driver comfort and the way that the passenger cabin even looks and feels to the driver.
Sure.
Opens up some possibilities there that are exciting.
Yeah. I think their one has a yoke, somewhat like the one on the Model S Plaid, but the Model S Plaid was still a sort of a conventional, like had eye shafts and linkage. So people griped about going hand over hand with that yoke. So that was pretty polarizing, but interesting stuff, man. Well, yeah. And sorry, you were, so at BWI, there was some in chassis. I wasn't sure if you ever got into steering or anything. Does GKN have any, do they get into like steering portions of the vehicle at all? Or is that probably no?
GKN Automotive is purely in the drive line.
Okay.
And
got it.
eDrive systems.
Got it. Awesome, man. So I know, right, and you said we're having this moment. EVs, like we've seen, I think in 2021, it was 6% of new vehicle sales, and that curve, once it got past that 5%, we've seen it kind of continuing to start to accelerate, and that's as a percentage of new vehicles sold, though. So not all vehicles on the road, but it's ramping up. But obviously, there's still some hesitance. There's still some barriers. I'm always interested in talking to like folks like yourself who are deeply into this space. Like, what do you see as the biggest challenges, I guess, that are out there still for mass EV adoption? What are the biggest hurdles that you perceive to be things that we need to address?
Sure. Yeah. So I can tell you a personal story about my own journey toward